Hey, what's up? Welcome to the second episode of Crunch Data Science. My name is Song. I'm with my partner Zhouhua to teach you data science using very interesting NBA topics. First, let me ask you a question. How would you evaluate a player? What is your criteria to differentiate superstar from all-star? So, to evaluate a player, there are lots of metrics. We can look at the statistics, basketball IQ, leadership, etc. But in my opinion, what really matters is the playoff performance. Because for any player who's chasing for the championship, playoff is the real deal. So in this video, we will share a framework that helps evaluate a player's performance difference between regular season and playoffs. And we will also apply this framework to 3 top NBA players and compare their performance. The technique we will use today is linear regression. This approach is basic but can be very powerful, still widely applied in all sorts of scenarios like finance and healthcare. The name consists 2 words, linear and regression. For regression, it means figuring out the relationship between x and y. Why do we need it? Because sometimes we are interested in y but cannot directly observe it. So we would depend on x, which is observable, and calculate y based on x. For linear, it's quite intuitive. Look at these 2 graphs. The one on the left shows a linear relationship, while the one on the right does not. So, put them together, linear regression is a method to estimate the linear relationship of the data. Let's look at an example. We take the data from James Harden's last season. The X is game score, which is a metric for efficiency rating. The higher score means higher efficiency. If you are interested in the formula, you can find it in the description. The Y is plus minus value. It means the score difference between the 2 teams while a player is on the court. This is how the data looks like. From the plot, the data looks correlated. When game score gets higher, the plus-minus value also tends to be higher. We can see an approximate linear relationship between them. But here comes the question. There are infinite many possible lines that look reasonable. How can we find the optimal line to represent the relationship? To make things easier, just for illustration purpose, we sample 5 data points to show how can we fit the best line. First, we use this formula, y equals to beta hat 0 plus beta hat 1 times x to represent the best line. Then, we calculate the distance in y direction between each data point to the line, denoted as d1, d2, d3, d4, and d5. The distance is also called residuals. So here's a new concept. Sum of squared residuals, or SSR. The way to calculate SSR is just as its name. Take the square of the residuals and add them up. If we substitute each residual with the function of the line, then we can come up with the new formula to represent SSR. The reason why we want to use this equation is because it provides a way for us to figure out the best line. How to do that? Here's the method. To find the best line, what we need to do is to find the parameter of the line function that minimizes the sum of squared residuals. Using this criteria, we can have the following solution. This mathematical formula is a little bit complicated and requires calculus knowledge. In this video, we don't need to dive into the nitty-gritty detail because the program like R or Python will solve the math for you. But if you are interested, I have included a link that contains the steps to derive the results in the description down below. In our example above, we know linear regression is about finding the relationship between x and y. But what if there are different x that are directly or indirectly related to y? In fact, we can include multiple x into the formula, and this is called multilinear regression. Next, I will hand over to Zhenhua. He will lead you through the further analysis and conclusion.
In this section, I'm going to walk you through this framework in 3 steps and apply it to a very popular player, which is Jimmy Butler. And first of all, I will talk about the data collected for this linear model, and then I will talk about the implementation of linear regression. Also, I will show you how to build a linear regression model in a very popular statistical software. At the end, I will share our findings. Now, let's talk about the variables collected for this linear regression. To evaluate offensive performance and defensive performance, we're going to build 2 linear models here. In the first model, the y we used is an offensive metric, which is called offensive rating, and it measures the number of points produced by a player per 100 total individual possessions. And in the second model, we use the defensive rating as y, which measures the number of points the player allowed per 100 possessions he individually faced while on the court. And these 2 metrics are developed by Dean Oliver in his book Basketball on Paper. Detailed calculation for these 2 metrics are shown in the description. In both 2 models, our axes are the same. They all represent characteristics of the player. For example, home or away, before or after COVID, and etc. And among all of these, the most important axe we will look into is whether the player is in playoff or a regular season. And we will use this factor to understand how a player performs differently between regular season and playoffs. With all the data in hand, let's answer the question, how Jimmy Butler performs differently between regular season and playoffs. We all know that Jimmy Butler had an excellent performance in the last playoff season, and he's the reason why Miami Heat was the champion in the Eastern Conference. And I have to say that after seeing his incredible performance, he became one of my favorite NBA players. Before jumping into our findings, let me first walk you through a very simple example of how to build a linear regression model in R. And just to let you know, R is a very special programming language designed for data analysis, and you can simply think of it as an advanced calculator. The first step is to load the data we have prepared for this analysis. In this case, we're using a very simple function called read.csv to load our file. Let's type in the location of our file. Then in the second step, let's build a linear regression for Jimmy Butler's defensive rating. In this case, we're using a function called lm, which is the shorthand for linear model. And we need to specify which data to use. And in this case, we're using Jimmy Butler's data that we just loaded. Now, let's also specify the formula of our linear regression. Since we're building a model for Jimmy Butler's defensive rating, the y variable should be defensive rating. And we also copy paste all the x variables here. And notice that y variable and x variables should be separated by a tilde. And the third step is to show the results of our linear regression. And fortunately in R, we have a very simple function called summary. So let's type in summary parenthesis reg, which is the model that we just created, and hit Command Enter. Don't be too nervous about all these crazy numbers. Let's focus on the coefficients in this model. For now, we do not need to understand the standard error, t-value, and p-value, and this will be covered in the future videos. The result shows that Jimmy Butler tends to allow 32.4 more points per 100 possessions in playoff season, holding all the other factors the same. Meaning Jimmy actually did worse on defense in the playoff. And this sounds very surprising to me because Jimmy really impressed us with his dominant performance in semifinals and finals. And my interpretation for this result is that playoff season usually gets more attention than the regular season, and his amazing performance in these two series really outshines his regular season's performance. So as a result, we falsely perceive that Jimmy performs much better in the playoff season. In the next step, we used the same method but with different Y. We built another linear regression model to look into the offensive performance. The result shows that we do not have enough evidence to show that Jimmy Butler is doing better or worse compared to the regular season. To make things more interesting, we also looked into Jimmy Butler's opponents in the final games, and they are LeBron James and Anthony Davis. Now, let's compare the playoff performance of these three NBA stars using the linear models we have. To do that, we set all axes to be the same. In this case, we assume that these three guys played in their home court, that COVID has started, and there is no game played in the last 10 days. Then we predict their offensive and defensive rating. The result shows that among these three guys, Anthony Davis has the highest offensive rating, and followed by Jimmy Butler and LeBron James. In terms of defense, Jimmy Butler achieves the best defensive rating, and followed by Anthony Davis and LeBron James. Due to our respect for LeBron James, we carefully looked into his data. Interestingly, we find out that LeBron's defense actually improves a lot in the playoff season, since on average, he stopped 38.5 more points per 100 possessions he faced in the playoff season. We have to admit that our method has many limitations. First of all, we do not have a large amount of data, since we only consider the players in the 1920 season. Also, our model might not be complex enough to capture the relationship between performance and its playoff. Besides, there might exist other hidden factors that also affect this relationship. So for the future study, we might consider a more advanced method with more factors. We also need to consider using more data.
Thank you for watching. If you like our video, please click the like button and subscribe to our channel. If there are NBA topics that you want to approach using data science, please also leave a comment, just so we might do a video based on your suggestion.